good evening, wherever you happen to be in the time zones. Evening from Dhaka, Bangladesh, where we are. It's my great pleasure to welcome everybody to this very interesting and very timely webinar on the recently released Working Group 1 report of the Intergovernmental Panel on Climate Change 6th Assessment Report. We are very lucky to have with us one of the key lead authors of the 6th Assessment, Working Group 1, lead author of Chapter 12, Professor Saiful from Bangladesh University of Engineering and Technology, or BUET. And we are also very pleased to have with us a discussant from the Netherlands, Mr. Bart van der Hurk, who is with Deltares in the Netherlands, who will also share his thoughts on the IPCC report. So before I give the floor to Professor Saiful, let me just say a few words about how we will run this webinar and also a little bit about the IPCC itself. In terms of how we will run this webinar, we have had an oversubscription of the 100 Zoom account that we have. Our limit is 100 people with a Zoom link, and we have had many more than that applying. So we are letting people in, first come, first serve. When we hit 100, then after 100, we will ask you to join us on the Facebook or YouTube links. These are both being broadcast live on both Facebook and YouTube, so you can follow them on YouTube or Facebook. We will also be accepting questions either in the Zoom chat if you are in the Zoom link, or on Facebook. You can send them in. My colleagues are monitoring Facebook and they will pass on your questions to me. But the way we will do it is we will have the main presentation by Professor Saiful, followed by the presentation by Bart, and then we will open it up for questions. And in the meantime, if there are questions already, I will be moderating the discussion and putting the questions to our two speakers to respond to. And I'm looking forward to a very lively discussion. Before I hand over for this particular session presentation, let me give a little bit of background on what is the IPCC, how does it work, and why is it so important. The IPCC is the Intergovernmental Panel on Climate Change. It is under two UN agencies, the United Nations Environment Programme and the World Meteorological Organization. They came together many years ago to set up the IPCC. The panel, the IPCC, is intergovernmental, so all governments of the UN are part of the panel. And then what it does is it commissions scientists from all over the world. It started with a small number of scientists, mainly from the developed countries. Many years ago, over the years, it has been producing assessment reports every few years. And now it is doing the 6th assessment report with thousands of scientists from all over the world participating in this exercise. It is one of the biggest collaborative scientific exercises anywhere in the world over many years that has been taking place. I had the privilege of being a lead author in the 3rd assessment report, and then I was also a coordinating lead author in the 4th and 5th assessment reports. So I've had a long association with it. I did not participate in the 6th assessment report because it takes a lot of time, which I don't have anymore to give. And the younger generation should be taking over. And Saiful, Professor Saiful represents that younger generation of scientists from Bangladesh. We have quite a few scientists from Bangladesh have participated over the years. Most of our work being on adaptation, we belong to Working Group 2, which is on impacts, vulnerability, and adaptation rather than Working Group 1. But Professor Saiful is actually a climate expert, so he is in Working Group 1. So Working Group 1 is on the science, Working Group 2 is on impacts, vulnerability, and adaptation. Their report will be coming out later. And Working Group 3 is on the actions that are being taken, mitigation and adaptation. Their report will be coming out next year. And then once all 3 working group reports come out, there is a final report, which is a synthesis report of all of the 3 working groups together. That will come out sometime next year. Then for each of these working group reports, there are a large number of chapters. They're more like 3,000-4,000 pages in very dense chapters, but they're all available on the website if anybody wants to see. And what we then have, what was released day before yesterday, is what is called the summary for policymakers, which has to be approved line by line by the governments. The panel met for more than a week. This time it was a virtual meeting. I heard it went very well. People were working round the clock to review every line and every word in the summary for policymakers, and they made it on time. Sometimes they run overtime, but this time they made it on time. So we had the working group one final report released and presented a day before yesterday, and we are very pleased now. And if you've been reading newspaper and watching the news, you will see that there's a lot of coverage around the world in the media on this report. So I won't say what's in the report because we have the horse's mouth. We have a Professor Saiful Islam, who is one of the lead authors of the report, who has very kindly agreed to give us a presentation on the report. So let me hand over to Professor Saiful Islam. Saiful, you have the floor. Please go ahead.
Thank you, Professor Saleemul Hurk. It's always a pleasure to be with you in any seminar or any conference, and it's really my honor to be part of this contributing IPCC, particularly the 6th assessment report. I was in the past was a reviewer, expert reviewer, but this time I get opportunity to contribute in this report. And this report, as Professor Saleemul already mentioned, that has published on 9th of August all over the world, together around 234 scientists and many more contributors in this report. And this report is a first working group report, and the next working group report will be published early February next year. That is on adaptation and impact, and then third report will be on the mitigation side. So I'm just going through the key findings of the 6th assessment report. I myself and 234 authors from 65 countries contributed to this report, and there are 14,000 scientific publications assessed, and there are also gender balance some way, not 50-50, but 28% and 72% men, and 30% new in IPCC. One of them is myself. And then 78,000 review comments and 46 countries comments on final government draft. As Professor Saleemul mentioned, that it was a huge session of 195 country representative was there. Government representative was there from 26th July to 6th of August. It was approved. So what are the major key findings I'm going to share you? It's already the co-chairs of and the bureau members shared, but I think it's the opportunity to, for myself, for over this region, I was going to expect, particularly South Asia. So I'm going to share in the context of global and regional context. And there are other panelists in this session. They also will show what are the changes we are expecting, considering the global warming. The recent changes in climate are widespread and rapid and intensified and unprecedented in thousands years. You can see also that there is a title in the statement that's in my language, Bengali. This is also IPCC doing for every reason. They try to involve people so that they can translate it to their local language, which can disseminate this message to the common people. Last 2,000 years, we have seen that the amount of warming never happened. It's unprecedented. You can see the 2,000-year reconstructed graph of the temperature, and this we are here. It's unprecedented in every respect, and this warming actually caused by the human. And this is simulation where you see the natural and volcanic and variability, and if there is no greenhouse gas emission, temperature would have been there. But if you insert in the numerical model simulation that greenhouse gas, you can find that that matches with the observation. So now it's clear that it is increase of warming is caused by the human activities. And right now, as of if you compare to 1850 to 1900, where we had good data of the past, to 2010 to 2019, you can find that about 1.07 degree temperature is increased. And effect on carbon dioxide concentration has been increased, and it is highest in the last 2 million years. Sea level rise is rising faster rates and fastest rate in last 3,000 years. And Arctic sea ice is lowest level in last 1,000 years. A glacier retreat is unprecedented in the last 2,000 years. We have seen that extreme heat and other natural disasters, they have become more frequent, more intense. Heavy rainfall become more frequent, more intense. World is observed drought increasing in many regions. Fire weather, which composed of the dry and wind condition and hot, those kind of weather become more frequent. Right now, you know that there is a fire weather we are observing in Turkey and Greece. So these extreme events become more frequent. Ocean is influencing many ways by human activities. It gets warms, it becomes acidified because of CO2 emission and losing oxygen. And also ocean has going through many other changes that I'm going to show in the next slide. Human influence in the main driver that is now undoubted, and hot extremes which have become more frequent and more intense. Ocean warming since 1970s and ocean acidification is observed every oceans, and changes in the frozen areas in the planet. We have seen that global retreat of glaciers since 1990s, 40% decrease of Arctic sea ice that I already mentioned from since 1979, decrease in spring snow cover since 1950s, and it's continuously decreasing. Unless there is an immediate, rapid, and large-scale reduction of greenhouse gas emission, limiting warming to 1.5 degree will be beyond reach. And this latest study report shows that within 2 decades, by 2040s, if emission is the present way continue, will exceed the 1.5 degree centigrade beyond that. So these are the projections. If you consider from today's to near term and the mid-term and far term, it depends on the emission pathway we are following in the future. So if we can do the drastic emission cut and more sustainable way we progress, so very low greenhouse gas emission, it is still possible to achieve 1.5 degree by the end of the century, or slightly more, like 1.6 degree, or it could be overshoot and then come back to the same level. But that needs a drastic reduction, rapid reduction of greenhouse gases. But if we even follow the low carbon emission scenario, we still have less than 2 degree centigrade by the end of the century. But these are the other scenarios that we are currently following, and that would lead to 2.7 degree or even higher temperature in the future by the end of the century. And each scenario here, you can see that how much it will progress with time. And if we go to the net zero emission by 2050, we can achieve our target by Paris Agreement, which is 2 degree by 2100, below 2 degree. And these are the graph which shows that how it will be going to by the end of the century, and considering the emission pathways. What will happen if the temperature is increasing? Every half a degree is matter. This report shows that changes of the regional mean temperature, precipitation, and soil moisture. You can see that if 1 degree affects continents and is generally larger over land than over ocean, and Arctic will be more warmer because Arctic amplification, and it will across all the continent and ocean is actually warming, and the more will be in Arctic region, and Antarctic will be warm in the long run. And this pattern will continue and also impacted the precipitation. You can see that precipitation is projected increase over the high latitude, but there are also spatial variation of the increase of the precipitation of different warming level. Like the reason I am living in Bangladesh and Indian subcontinent, that will be increase of the precipitation, but some of the area in the world that will decrease in precipitation. So decreased parts of the subtropic and limited areas in the tropics. But the reason we are living and many other monsoon region will be increasing precipitation in the future. The increase of precipitation also increase the soil moisture, but it also varies due to the influence of the high evapotranspiration. So these are the figures that you see that especially changes in many regions. And there is a relative small but absolute changes may appear larger when the express unit standard deviation dry region and little internal variability in the baseline condition. One of the key assessment is that 2 degree increase that we are hoping Earth can limit. But if each 1 degree will be increasing 7% intensify the extreme rainfall. And there are also other assessment here. It shows that each of 0.5 degree increase or 2 up to 4 degree increase, how much we expected the extremes in the climatic extremes in the future. Like hottest day in a decade, the present condition is 1.2 degrees centigrade. But if 1.5 degree increase, the extreme hot day will be 1.9 degrees centigrade warmer than the present. And if it is 4 degree increase, it will be 5.1 degrees centigrade increase. The drought that occurs once in a decade will be increased 3.1% by 2 degree increase and 5 times more by 4 degree increase. Precipitation, which is wettest day in a decade, is currently is 1.3 times, but it could be up to 2.8 times more in a warming of 4 degree world. Snow cover extent currently change is -1%, but it could be go up to 25% by 4 degree increase. Tropical cyclone, the proportion of the high category cyclone, like 3 to 5 category, currently it is in 1.5 degree it will increase 10% and 4 degree it will increase 30%. So you can see that human impact and continuous emission will change temperature, extremes, drought, precipitation, snow melting, and also tropical cyclone, high intensity tropical cyclones. And some consequences will be very long term. It will not stop by 2100. It will continue. And expected that 1 point rise temperature with global warming will cause 3 meter by 2000 years. And 7 meter rise of the sea level by 10,000 year commitment. So it's already rise about 20 centimeter, and it could be go up to 1 meter by 2100, and it could go more beyond 2100. So these changes may not be stopped, but it can be slowed down, and some cases it could be stopped. That indisputable that human activities are causing climate change, making extreme climate events, including heat waves, heavy rainfall, drought, and more frequent and severe. We can see that the observed warming driven emission by human activities, and it is now confirmed and these are mostly contributed from the carbon dioxide and then other greenhouse gases. You can see the carbon dioxide is the most responsible, and then methane, nitrous oxide, and other greenhouse gases. But it also, IPCC mentioned that this report that aerosol is doing some cooling. It must. If the aerosol cooling is not there, we could have seen more increase of the present warming. And this report has one unique feature. It not only 30% of the report actually focus on the regional level, and here more than 30 continental regions and 12 ocean regions showed in this report. And each report, the changes now shown, like we are in Bangladesh, we are in South Asia region, and each changes has 4 directions. It could increase or decrease, and also the agreement type and the confidence level with high, medium, and low, so that policymaker can get a clear view what we are going to expect in the future. And we can see that synthesis observations at hot extremes is contributed by the human activities, and many reasons, actually almost all the reasons, is now experiencing hot extremes. In terms of heavy precipitation, many reasons in precipitation increase. Some of the reasons, the low agreement and limited data, and in Bangladesh and Indian subcontinent, increase of precipitation has been observed. And for the changes of agriculture and ecological drought, many reasons is observing increasing drought because of high evapotranspiration, because of the warming, and all these consequences we can see, particularly African region, some European regions as well, American regions, and Australia as well. So these changes is not equal so the challenges is different for different parts of the world. And this report shows the regional changes for every continent. And it also shows the changes of various atmospheric climatic system states, which can termed as the climate impact drivers. That means it could be mean change, it could be extreme change, it could be episodic change. So these changes are like hot and cold, rain and drought, snow and ice, winds, coastal ocean and others, and open ocean has acidification, like open of deoxygenation. So this unique terminology of climatic impact driver is introduced. In the past, we have seen that hazard is introduced, which only shows the negative consequences, but this time climate impact driver shows that it could be positive, it could be negative, or it could be neutral. And it impacted different sectors, it impacted different reasons, different ways. So this, in every reason, we shows this the different climate impact driver, how it's expected to change with the warming and with the time we are progressing. And here you can find a summary of the how climatic impact driver will be changed and expected to change, and with high confidence or medium confidence. And also in the each reasons, the change of climatic impact driver is provided. You can see in the chapter 12 where you can find reason wise. This is a global summary, and so many reasons we have high confidence that the temperature, precipitation, and other very climatic impact driver has been changed, and it continue in the future. We have seen that climate change impacted the water cycle. It has atmosphere can hold more water, more faster evapotranspiration, heavier precipitation, and intensify dry seasons and droughts. And this IPCC 6th Assessment Report Working Group has a unique features, interactive atlas. My other presenter panelists will show how it will be over this reason, but I'm just indicating that Any region of the world, you can change, you can see what are the possible changes by changes the variables, changes the data set, reference period, and changes with the different emission scenarios. So you can easily, that could be very useful for policymaker, students, or researcher, or even common people to know that what are we are expecting, what will be happen if we follow this pathway. And it can even show the seasonal changes over the region. So it's a unique data set, and it can be saved as the image. It can be used for different reporting purposes. So this interactive atlas can be accessed through this interactive/atlas ipcc.ca. And in the future, you can see that if we have 1.5, 2 degree, 3 degree, or 4 degree temperature, how the temperature will be changed, how the precipitation will be changed from this interactive atlas. So it is now know that from this assessment, climate change is already affecting every region in the Earth, multiple ways. Changes, experiences will increase in the future warming, and there is no going back of some of the changes, unfortunately. And we see that ocean temperature is increasing, inland ice sheet is melting, sea level rising. These changes will continue beyond 2100. But some changes can be slowed down with drastic emission reduction. Some changes can be stopped by limiting warming. There is no going back from changes, some changes. However, some changes could be slowed and limiting. And we need strong, rapid, and sustainable reduction of CO2, methane, and other greenhouse gases reduction. And it is necessary not only to reduce the consequences of climate change, but also it improves the air quality. And it is now unequivocal that we found in this report that if cumulative emission and temperature is almost linear relationship, and proportion of carbon dioxide emission taken up by land and ocean carbon sinks is smaller in the scenario with higher carbon dioxide emissions. That means in future, currently land and ocean absorb about 56% CO2 emission. But in future, this proportion will be less. That means more carbon dioxide in the atmosphere, it will be more warm. And different scenario, you can see the contribution of the CO2 and other greenhouse gases. It is found that CO2 will be the most dominant in the past and the future emissions. And the more emission scenarios, that will be CO2 emission will be more in the atmosphere. So that's it, but you can go through the whole report. There are so many, more than 3,000 pages, so many scientists has contributed, and this another 2 report also coming in the next year, and there will be also synthesis report of these 3. Thank you very much to give me the opportunity to show some of the key findings, and other over this reason, I'm happy to answer you, respond to your question and comments, if any.
Thank you very much, Saiful, for that excellent presentation. I really am very happy that this 6th assessment report has made the data sets available in the interactive atlas. You know, I have been arguing for many years with IPCC to make data available at the regional and local level for other scientists to look at. But I guess the technology was not available before. But it's very good to see 6th assessment has done that, particularly working group 1. Again, let me remind everybody, if you have questions, please write them in the chat box. I will take them later and present them to either Professor Saiful or to Bart. But let us now hear from Bart van den Hurk from Deltares in the Netherlands. Apologies if I mangled your name. Please I'll let you introduce yourself as well. Bart, please go ahead.
Thank you, Salim, and thank you, Saiful, for a very nice introduction. Yes, I'm Bart van der Hurk, and I also had the pleasure to be one of that 30% newcomers to the IPCC process. I participated in the chapter that has been referred to before. It's called the Atlas chapter. And I'll go and present a few things from that atlas, because it's indeed intended to give access to that wealth of information to a much broader audience than just the scientists. A bit about myself. I'm working at Deltares, which is a water investigation company in the Netherlands. There is a very effective collaboration between the Netherlands and Bangladesh institutes at say policymaking level, but also at the knowledge level. Deltares is part of that. And we are joined in a program which is called the Joint Cooperation Program. And this is just an introduction slide that lists a number of activities that are taking place in the context of that joint cooperation. But I really encourage these kind of collaborations, because this is really the way to work together on collecting the knowledge that is needed to get our societies into a much more resilient state. So I'm happy and proud to be part of Deltares that is working in this collaboration with Bangladesh. Before I'll display a few points from the atlas, I would like you to think about a couple of take-home messages, and these are very personal for me. So I've been, of course, engaged in a process like Saiful for 3 years and longer. We've worked very hard to make this report, and these days, of course, this was like a pressure cooker, because so much energy got out into society and so much interviews were given about the report, and people continuously ask me, okay, but what's the most important for you? And I think what I've seen already happening these days, this report is being interpreted as a very alarming signal again, and timely. We have a new negotiation round coming up in Glasgow this fall, and it's important to frequently update the state of the climate information to support these negotiations. But I also see that people, sometimes get into despair, and people ask me, aren't you despaired about what you'll see? And of course, yes, there is a lot to be negative about, but also I think the report shows very clearly that there is choices to be made. There is different scenarios, there is different futures, there's different adaptation options. And I think as a scientists, we should also keep on working on these options to fight the problem and to adapt to the changing situation. So it's not only an alarming signal, we also should convey the options that are useful to elaborate. A second take-home message, very relevant for both Bangladesh and the Netherlands and many other countries in the world. Low-lying delta regions are, of course, explicitly exposed to climate change. And we know that already for some time, and we experience the adverse effects of heavy weather in our countries and other nations. But it is reconfirmed again. We have sea level rise. We have the rivers that change their, say, seasonal cycles, and in Bangladesh, particularly so because of the huge impacts of climate change on the hydrology in the upper Himalayan mountain ranges and the glacier and snowpacks.
Bart, can I interrupt?
Yes, of course.
Can you just check your screen? I think you maybe have put the wrong screen on. We don't have slides from you. This is my Daily Star article that you've got on the screen.
Oh, sorry about that. Yes, okay, sorry. And good that you interrupt me.
I was wondering what happened.
Oh, okay. Sorry, this is the one.
Yeah.
It's now correct? Okay,
yeah,
sorry.
now it's correct. Yes, go ahead.
Okay. Let me very quickly, this was the slide on the Joint Cooperation Program. To have a quick short, the slides can be shared.
Yes,
and
we can share the slides later on, so don't worry about that.
Yeah, thank you for interrupting. I didn't take notice. So the second part, low-lying delta regions, sea level rise, the variable river discharge. In the tropics, we also face issues with the combination of higher temperatures, but also high humidity levels, and which is pretty, say, demanding for humans, but also other species that live in that region, which is a very important climatic impact driver that is being assessed. And of course, we are looking at areas where very often a lot of people live. More than 10% of all inhabitants on this planet live in areas below 10 meters above sea level. So and 15 out of the 20 megacities are in that zone. So it's a huge population that is affected in these areas. So for that area, climate change is very important. And my third take-home message is that there is lots of assessment of the mean changes of the climate features, and Saiful made a couple of examples of that. But we also, particularly also for this region, which is dominated by monsoon precipitation climates, for instance, it's not only, say, the means that are exposing changes in response to global warming, but it's also the interannual variability seems to increase quite a bit. We have larger differences between extremely wet or extremely dry years in specific regions. And that may have implications for how well this climate is going to be predictable and how well we can rely on a given state of the hydrology and the state of the climate system in order to practice agriculture or civilization in general. So important region. Let me show you two resources that are maybe useful for further exploration also by the non-scientists. The first one wasn't mentioned yet, but we also made so-called regional fact sheets. And these are very short, very short summaries per continent, only 2 pages for the entire region of Asia. So this is highly condensed take-home messages of what we observe and what we project in terms of the major changes for that continent. And apart from, say, a generic picture for Asia as a whole, there's also a small box that has a couple of lines that relates to the South Asia region where Bangladesh and India are in. And again, it's very high level, it's very generic, but it is a good sort of starting point for many discussions with students, with policymakers, with people in industry or whatever. And I really recommend you to go and check out that repository that is also on the IPCC website. The URL is on the bottom of the slide. And then second, already introduced before, is indeed the Atlas. It was indeed a technical challenge to display all this information. But for those who have already seen the previous IPCC report in 2013, the AR5, the fifth assessment report, you may remember that in the end it was a very thick package of appendices or annexes with all kinds of maps, with projections, etc. And it becomes out of hand. There's too much to show. And for sure, when you go into regionalization, there's too much to show. So actually, the technology is now used to show it, but not at the expense of having such a thick report. So most of the figures that you see in the IPCC report are produced using the Atlas, but you can go to the Atlas and to make small changes to the reports that are included in the assessment report. So you can change the selection of models or the time window or the scenarios to have a much richer, information about the climate change, both in the observations and for the projections for the region of interest. We also included regional climate model simulations in that atlas, and also for South Asia, a major so-called CORDEX, which is an acronym for a regional climate experiment, have been included in the atlas, and the information is assessed at a much higher resolution than these global models. And that is really a technological revolution, I can say. It's many terabytes of data that are actually underneath this atlas, and it's being processed in a way that is accessible to also non-experts. What you can do is here, you can see the blue shading area. I can zoom in, and then I can produce a couple of, say, specific plots for that region. And this is just one example. I could have picked 25 different examples to show here, but this is one example which just shows the change in the precipitation annual cycle for that region for a 2-degree warmer climate. And you can see it's not a very large signal. There is quite a bit of noise because we have used multiple models and they all have a bit of a different expression. But on the end, the mean precipitation change for this climate region is not very pronounced. However, you can change for a different warming level, and then I go to a 4 degrees warmer climate, which is hopefully way ahead for us. But then, of course, you can really see that the signal becomes more prominent. And so as a simple comparison between these scenarios already gives you a good insight of what climate change can do to a very large range of variables for that region. And again, the URL for that atlas is here. We are busy with preparing video instruction videos that guide you through the atlas, that gives you more information about all the models that are being used in the data. And these tutorials will hopefully help you to make yourself familiar with the interactive atlas. I think I leave it here. Sorry for the confusion about the screen that I selected, and I'm more than happy to answer questions if appropriate. Thank you.
Great. Thank you very much, Bart, for that excellent update and additional information on what Saiful had done. So we will now open ourselves up for questions from the audience. I see there's one already from Mr. Isfatuzzaman Bhuiya, who is a PhD researcher in the Netherlands. Saiful, would you like to have a look at it? It's quite a detailed question for you.
Yeah, I already saw that.
Good. Why don't you respond?
Yeah, thank you. I think this is a good question, that why dry region get drier and wetter. It's because of the way world is, the circulation pattern, the way the region is located, because the rainfall and temperature has a cycle, particularly precipitation has followed, like we are in monsoon region, so 80% precipitation occur during the monsoon. So that's why because of the warming will be high, evapotranspiration will be high. Some regions which has less precipitation will be dry, region will be more drier. On the other hand, since the more evapotranspiration and more moisture is held by atmosphere, the wetter region will be more wetter. And one question I just like to share my screen, maybe that will be useful for you. You have mentioned that is all figures. There is no table. I think I request you to go to the technical summary, which is now approved in the final session, where you can find table TS1, table 1. You can see the near term, what will be the changes of the temperature with different scenarios in the mid-term, long-term, and even different global warming, what is the changes we are going to expect. So this table will provide it. And there are many other tables in the 3000 page report. So hopefully those will be useful for your further interest and research. Thanks.
Thank you very much, Saiful. So I have a question for you, Saiful.
And, I'm worried.
You are the expert. I am not. So my non-expert question is that my impression from the global models has always been that when you and I sitting in Dhaka, Bangladesh, ask a question about what's going to happen in Bangladesh, we are so small that the global model maybe has one or two, data points in Bangladesh. So, has that improved? Is it now better? Are we able to have a little bit more detailed downscaling to the size of a country like Bangladesh, or are we still part of the South Asia monsoon, and that bigger downscaling system is what governs everything? And we, making differences between Chittagong and Dhaka and Joshua, this is not possible as far as I'm aware in the UN, in the IPCC system. But tell me if things have improved or not.
Yes, Professor, the things have been improved a lot over the year. And you can have many, many points. And also Bart mentioned that there are regional downscaling Cordex initiative where you can go up to 50 kilometer, or some high resolution models which can go up to 10 kilometers. So a numerical model, not only improving the resolution, but also the internal physics. Like now we have art system model, which see the carbon cycles inside inside each grid. So the models are improving. Plus, it is supported by observation, satellite observation, different observations from sea, from ocean, and from the land. So those are becoming more and more confidence. Like in the past, we don't have much information about sea level rise. Now we have satellite altimetry data. We have accurate estimation of sea level rise. So these are positive things, and hopefully
Excellent.
it will be more accurate.
Very good. Very good. Catherine, please come on in. You have to unmute.
Oh, yeah, I can. Thank you very much for organizing this very interesting session, and also to bring up this point about climate change facts for Bangladesh. So this is what we really need. So we need to continue to measure in the country the different facts regarding the climate change, because the country itself is known for a huge climate variability. And the IPCC report shows that the extremes are more and the variability is more. Now, we already knew that in Bangladesh the variability was a lot, but does it mean that from a lot it is even more? So we need to continue to collect facts on that so that we can know better, because we cannot rely only on the global models. To collect data in the country will help us to link it to the global models. It will actually improve the global models, but it also will help us in the country to kind of translate to people what we think what will happen. And some people argue that climate change is or is not happening in Bangladesh because you cannot see it easily because of that huge variability. I think that discussion, we can leave it behind. We know it is happening, but we will need to continue to collect facts, because facts will help us understand, and we cannot expect IPCC to deliver us those kind of facts. We will need to do it in Bangladesh.
Excellent. Very good, Catherine. Very good point. Saiful, if you have a look in the chat box, there's a similar question from Saqib asking, what will the government or what will we do in Bangladesh with the IPCC sixth assessment report? Is there something more we can do together here?
I think you are the best person to respond.
No, you are the AR1 expert. You have to tell us what more can we do in terms of explaining the issues for a Bangladeshi audience. The question is always, what does it mean for us? And you have to explain it, to a Bangladeshi audience. What does it mean for us?
Yeah, that I can explain, but they ask also what is the policy intervention. I thought you were the best.
Yeah, that I can help you.
Okay.
But the physical part, you have to tell us.
Yeah, okay. First, I start with some comments that Catherine mentioned. It's excellent comments, and this is a fact and reality. A widespread, actually, the changes is observed, which is primarily, unequivocally, it's caused by the human activities, and now this report confirms. And there is also disbelief, like 20 years ago. It is still some point people thought when the natural variability is more, then they thought it could be happen just because natural variability, any extreme event. But in this report, you can see there are improved attribution study, event attribution, which shows that many extreme events is caused by, we can attribute that it can caused by the greenhouse gas emission and global warming. And also there is a new term this report has introduced that is called emergence, which is the ratio between the signal to noise. The signal is the changes due to the global warming, and noise is from the natural variability. If signal to noise ratio is more than 1, we assume this phenomena is emerged. And there are a table in chapter 12, you can find that how different climatic impact driver will be emerged. We have seen many already emerged, but within the next 30 years, by 2050, many climatic interdriver will be emerged. So it will be very interesting. And then second point from a participant, that what we can take from this report, Saki. There are actually already Bart mentioned the South Asia region. We are expecting at least two phenomena very high confidence. One is heat extremes will be increased, which include the heat wave, which include the dry condition, and also the heavy precipitation that could lead to flooding. In the sea, we see the sea level is rising. It will continue beyond 2100. So that will bring a lot of issues in Bangladesh. Particularly, our coastal border needs to be raised because salinity will be increased. We also are going to see more storms of category 3, 4 going to come in the future. Proportionately will be increased. That means we have to prepare for a storm surge and under sea level rise condition. And urban area, increasing precipitation we'll see. In the Howrah area, we'll see flash flood will be increased with intense precipitation. So many different aspects, and particularly agriculture will be affected a lot because Bangladesh is an agricultural prone country. Bangladesh is known for agricultural country. So we have to prepare for the worst climate years in the coming decades, unless greenhouse gas emission is continuing. And I would request Professor Hurk to respond on policy levels and how we can tell the world that Bangladesh will be more vulnerable if we are not doing greenhouse gas widespread reduction. And Bangladesh is already taking some policies on adaptation, and Bangladesh made its Delta Plan 2100. So that will be bring a lot of, I think, try to reduce some of the adverse impact.
Excellent.
So here.
Excellent. Thank you very much. Let me very quickly respond to you, Saiful, with a suggestion that why don't you and I co-author a quick piece on, you do the science, I do the policy implications, and the quicker we do it, the better, because as you know, the National Adaptation Plan is now being developed. We should get it to them so that they understand the implications of the output of AR6 for the NAP in Bangladesh. So we have an opportunity to give inputs. I see Bart wants the floor, but before I give you the floor, Bart, I'd like also to ask you and also Catherine to give your thoughts to something I'm going to propose, which is how can we develop better cooperation and collaboration in the scientific level between Netherlands and Bangladesh. You've mentioned that there is a long-standing relationship. That is true. It has happened in the water sector for many, many years. But now can we take it into the climate change arena, particularly in the impacts and adaptation arena, and collaborate? Because, you know, the two countries are so geographically similar. They're technologically and economically dissimilar, but geographically very similar. And so, and many Bangladeshis go to the Netherlands to study. That's a big resource, potential resource that we have to invest in doing further collaborative research going forward. So I would like you to also, in your remarks, reflect a little bit about ideas that we might be able to take forward out of this conversation, and then follow up later on bilaterally. So Bart, I'll give you the floor, and then Catherine, I'll ask you to come in as well.
Yes, thank you. I think this is an excellent opportunity to make the point I was planning to make, and that is, Catherine made a mention that people don't see climate change so easily in an area where there is such large interannual variability and with such a large seasonal cycle. But we do see it's there. It may be difficult to see directly. The emergence may be low, but it is there. We can witness it if we look closer. I think what we should develop jointly a bit better is a climate analysis that does not only look at, say, mean trends or mean annual cycles, but has much more intelligence in interpreting variability. I think we have to look at what kind of large-scale conditions give rise to very persistent droughts, multi-year droughts, or multi-year warm episodes. We learn a lot about how ENSO is behaving, But climate change may trigger other modes of variability that have an enormous impact. We have to learn a lot about, say, the hydrology of the Himalayas in a far future, for instance. We have to learn a lot about the sea surface temperature patterns and their impacts of climate. And I think our climate analysis should not only look at that long-term trend, but really look on what is governing the weather at more annual timescale. And I think if we can educate our master and PhD students for that kind of analysis, that is both for the scientific arena, it's a huge asset, but it's also much more informative for, say, the local adaptation planning and the early warning planning.
Absolutely. Very good, Bart. Thank you. In fact, you know, one of the big revelations for me in the sixth assessment report, which I've written in my Daily Star article, is the improvement in assessing the climate change signal in extreme events. It used to be the case that the models were very good in the long term, 2050, 2100, but they didn't say much about what's going to happen to variability, the up and down lines that are taking place.
Exactly.
Now they're much better at that. And that's what we are concerned about. Is it going to be a big flood, severe flood? And, you know, doing more on these extreme events and likelihood of their increase or becoming exacerbated is something that we can do.
Yes.
I remember we had a PhD student who did her PhD with Miles Allen in Oxford who looked at extreme rainfall in Chittagong, for example. Remy, she did a very good PhD on that. So, you know, in my mind, there are many good PhDs to be done here together.
Yes, exactly.
on focusing on the extreme events rather than the long-term models, taking them to 2100. So Catherine, please give some thoughts on how do we improve our collaboration between our particularly young researchers in the two countries going forward.
Yes, I must apologize because I need to run witin 4 or 5 minutes.
We'll finish in a few minutes anyway, so please go ahead.
But I do like to be given the opportunity to reflect on this, and I agree very much with what has already been said, and about the need for capacity on climate change kind of science. But we also need to be able, and also Mr. Volker de Jager from the embassy already put that also in the chat, we need to translate that to water and agriculture, and how are we going to do that? And in that regard, it's not only the science that needs translation, it's also the dialogue that needs to be shaped up. So I was very pleased to see a lot of Bangla in the presentation of Saiful.
Exactly. Very well done,
We need
Saiful.
to be able to talk in normal Bangla to normal farmers in Shatkhira or wherever about what is kind of happening and how they are seeing it, so that we get capacity to adapt. And that capacity to adapt, we need that at all levels. And yes, I would be very happy to work with you together on that, and we can look for ways and means how the Dutch government also can support that. But I also hope that it will be very Bangladesh based and very Bangladesh strong. And that, for instance, the professors of BUET will also be in Shatkhira to talk with the farmers about these kind of things. So that will be very important. You mentioned that there needs to be a piece on how this AR6 and NAP need to be linked. If you need support, let me know, or Bart support. We will wish to help you. But you will guide us, and we will be there. And I still share the dream with you, right? That all master students in Bangladesh know something about the Delta Plan. And that's not because the Delta Plan is so great, but because it is a way of thinking towards the future, and that with that future in mind, you determine your thinking nowadays. And if we can increase that ability, I think Bangladesh has shown over the last 50 years that it can build up and it can sustain and it's strong. And I think that this flexibility and this strength should not be lost. Whatever vulnerable it is, I think Bangladesh can be strong as well. So we need to work on that. Thank you.
Thank you very much, Catherine. We are coming to the end of our allotted time, and before we close, and I thank our two designated speakers and all the other participants who participated with questions, let me give a couple of concluding thoughts, which are actually next step thoughts, which we have already discussed. So firstly, one next step, Saiful, you and I will talk and see if we can write something quickly in terms of what does it mean for Bangladesh, 6th assessment report. You do the science, I'll do the policy, and we'll write something quickly together. And then with Catherine and with Bart, we'll have a slightly longer term conversation as well on how do we collaborate in doing further research, more master's students, PhD students on a regular basis, Dutch students coming to Bangladesh, Bangladeshi students going to the Netherlands, and then connecting all these students with higher degrees who can do further research and collectively enhance our research capabilities, because these things are ongoing problems. There is no one-off solution, and climate change is now a reality for the whole world, but definitely for Bangladesh as well. And the concluding remark that I will share with the audience is what I have written in my article. In my view, the 6th assessment report, Working Group 1 report in particular, is really the 6th assessment report of Working Group 1, but is also the first IPCC report on loss and damage from climate change. We now have attribution to human-induced climate change. Very, very strong attribution. This was missing until now. It is now provided by AR6, and there is no going back. This is going to continue. This is the future. The future will only get more and more strong attribution to the signal to noise that Saiful mentioned. The signal is going to get stronger and stronger, and there will be emergence in many different spheres, in many different locations going forward. And so that's a very serious implication for vulnerable countries like ours, but also for the global system, particularly to spur action to keep global temperature below 1.5, which is slipping away by the minute. You know, time is of the essence. We are almost certain, I don't want to say certain, but almost certain to cross over 1.5. We may be able to cross over and come back. That's a second order question, but we want to stay below. And our ability to stay below is diminishing by the day. So we have to make stronger and stronger efforts at the global level to make sure that we stay below 1.5. We have not lost it, but it's going to be very, very difficult. So I want to thank Saiful for an excellent presentation, and also Bart for complimentary sharing of information and a good discussion. And thank everybody who participated with us. We will be sharing a recording of this. So if anybody wanted to join and wasn't able to, they can watch the recording. Our experience with webinar recordings, by the way, is that they get quite a big audience. There's quite a lot of appetite. Not everybody can come for the the live meeting, but they can watch it in their own time. They like to do that, and it's very good resource for many people. It's a document. It's a video document of what has happened, and we will share the PowerPoint presentations to all of you who have given us your email addresses. If we have your email address, we will be sending that out to you. If Saiful and Bart can send them to us, we will then share it with everybody else. Excellent. So thank you all very much. If I can just ask before we close, people to just put your cameras on so we can take a screenshot of everybody who's attended the meeting with us. Please put on your cameras. And let me ask my colleagues to make sure that we get a photograph. I'll do a countdown from 5, 4. There's still a few others who haven't put their cameras on. 3, 2, please put your cameras on. There we are. I think we are more or less everybody there. Please take a photograph. Are we done? Can somebody signal? Sakib, have we done?
Yes, sir.
Okay, great. Thank you very much, everybody. Thank you.
Thank you, sir.
Bye-bye.
Thank you, Bart. And thank you,
See you,
everyone.
Saiful.
Thank you. Bye-bye.